Hey ISTEM, as you know, I've got a really big family and we run out of bath towels all the time. Here it is, the shelf for our bath towels completely empty. We run out every 2 weeks and Sunday, today, is towel day. Let me tell you how it works. When we throw in a load of laundry, we put in 3 or 4 towels per load, and so at the end of 2 loads, we have 7 towels on this shelf. So here's the question I'm trying to figure out. If I know my family has 28 bath towels, how many loads of laundry do I need to do to fill this shelf up again?
So, as the problem's been stated, for every 2 loads of laundry, 7 towels are cleaned. If we think about what we did last week, this is like describing a relationship with words. Okay, so let's take those words and let's start by turning it into a table of values. So I'll just call this X and Y to start. And I know that when I haven't done any laundry, I don't have any towels that are cleaned. When I do 2 loads of laundry, I have 7 clean towels. So here X is the number of loads of laundry, and Y is number of clean towels. So I start with 0 loads of laundry, 0 clean towels. I have now 2 loads of laundry done, 7 clean towels. When I do 4 loads of laundry, I would have 14 clean towels, and so on and so on and so on. Let's clean this up a little bit. So we learned last week about patterns and first differences, and we can do some first differencing calculating here. My first difference would be my Y value, 7, minus the Y value above it. So I get 7. 14 minus 7 is 7. 21 minus 14. And so on and so on and so on. So as I do my loads of laundry and as I add towels to my closet, you can see I'm adding 7 every time. This is a consistent number. It's the same number, which tells me that this is linear relationship. We could look at this as the rise. So if I want to find the slope of this relationship, slope is rise divided by run. Okay, my rise is 7. Now normally when we calculate first differences, our x values go up by 1, but here we can see that the x values are going up by 2 every time. Well, that corresponds to a run of 2, which makes sense. For every 2 loads of laundry, I clean 7 towels. 7 divided by 2 would be 3.5. So I've got an equation in words. I've got a relationship in words. I can make a table of values. I can even create an equation. Since I know the slope, 3.5 times x, and since I know my y-intercept is 0, my equation is a real simple one, just y equals 3.5x. I can take all of that and I can turn it into a graph using Desmos or just sketching it. So here you can see I've created my graph. I've done some dots to make like a scatter plot. That represents each 2 loads of laundry going up by 7. That represents each load of laundry cleaning 7 towels. And I can connect that with a nice straight line. And there I've done my 4 different representations of this particular problem. So my closet's empty. Every 2 loads of laundry I clean 7 towels. How long will it be before I have all 28 towels cleaned? Well, you can see my 28 towels are cleaned after 8 loads of laundry.
Bigger problem happened today. After 6 loads of laundry, our laundry machine broke, and now we're stuck with however many towels we were able to get done. So I need to figure out, and you're gonna help me, how many towels per day can we use in my house to make sure that those towels stretch me for 14 days.
Our second problem here, my laundry machine is broken after only 6 loads. How many towels can my family use per day if it takes 2 weeks to fix the washing machine? This would be another example of a problem being stated in words. I think since I know I was doing 7 loads of laundry every 2 loads, so in 6 loads I would have, let's go back to that original equation, which was y equals 3.5x. In 6 loads, I would have how many towels done? Let's calculate this. Y equals 3.5 times 6. That would be 21 clean towels. I know it needs to last me 2 weeks or 14 days. I think it might make the most sense to turn this into a graph right now. So I've drawn a little graph here. Starting at day 0, I know I have 21 clean towels in my house. And following this line all the way to day 14, by day 14 I've run out of towels. I need to figure out how many towels I can use per day. That's like a rate of change. And so I'm going to first find the slope of this line using the equation y2 minus y1 over x2 minus x1. I say use the rightmost point as your x2, y2, and this would be the point 15 and 0. Y2 value is 0, the x2 value is 15. I'm going to subtract x1 and y1, which is the point 0 and 21. So I'm going to subtract 21. 15 minus 0, I get the fraction, negative 21 over 15. Dividing those two numbers, I get a rate of change or a slope of negative 1.5. So I can turn this now into an equation. I have the equation y equals negative 1.5x plus 21. That's my y-intercept. It's interesting because this is a partial variation because the y-intercept is other than 0, anything other than 0. So we have a partial variation here. I started with words. I made a graph. I've made an equation. Let's quickly make a table of values, x and y. So on day 0, I had 21 towels in my closet. My slope, I use a towel and a half a day. So it doesn't make sense to use half a towel. But on day 2, I would have used 3 towels. So 21 minus 3 would be 18. On day 4, I've used another 3 towels. So I'm down to 15 towels. And so on, and so on, and so on. So there's our word description of the problem. We've turned it in this example into a graph first, then we made an equation, then we made a table of values.
So here's your assignment, ISTEM. I made up a little math problem with towels. You are going to make up a problem in your household about something that grows and then shrinks in a predictable, linear kind of way. So the instructions are in your assignment. I'm looking forward to seeing what you can do. See you later.